Hej och välkomna till dagens webbinarium som fokuserar på hållbarhet kring belysning. Idag sänder vi ifrån Trilux i tyska Arnsberg. Trilux som vår stolta partner är en av dem vi jobbar mycket med. Jag håller på att fibbla med presentationen här under tiden om ni undrar varför. Men som alltid så är avsändare för det här webbinariet och det som vi gör Annell. Och, höll jag på att glömma det allra viktigaste. Under tiden vi kör den här dragningen, glöm inte bort att ställa era frågor, så svåra frågor ni vill ha eller vill ställa. Uppe till höger någonstans finns där en frågor och svar där ni kan skriva ner era frågor som vi tar efteråt. Jag kommer inleda med en dragning från mitt perspektiv och sedan så kommer Sebastian ta över med sin expertkompetens. Lite kort om Annell, ni känner säkert till oss, men vi arbetar med belysning på flera nivåer. Det här gör vi för att vi vill kunna erbjuda ljus även till de som inte har oändliga resurser, men som värdesätter ljuskvalitet. Vi väljer aktivt att kombinera en liten egen utveckling med försäljning från utvalda delar av europeiska kvalitetspartners. Vårt mål är att underlätta för ert arbete som föreskrivare genom att erbjuda ett slags smörgåsbord med bara russinen och guldklimparna kvar. Allt det där medelmåttiga undansopat, bara det som är riktigt bra kvar. Och slutligen så lägger vi rätt mycket resurser och fokus på att försöka sprida kunskap kring ljus. Bland annat genom webbinarier, seminarier och det här webbinariet som ett. Ni ska som sagt få höra Sebastian Knoche om en stund, Dr Sebastian Knoche. När vi pratar vidare om hållbarhet. Jag vill börja med att framhålla att jag är absolut ingen expert på det här ämnet. Jag undviker helst att ge absoluta svar kring frågorna. Och jag vet att Sebastian, även om han är sjukt mycket duktigare på ämnet än vad jag är och verkligen en expert, så undviker han helst också de absoluta svaren. För så här är det. Hållbarhet är oerhört komplext. Och vi bör alla förhålla oss till det med stor ödmjukhet. Så det blir inga quick fix idag. Om någon hade förväntat sig det. Däremot blir det förhoppningsvis tänkvärda idéer och funderingar att ta med sig frågeställningar i ert arbete för att skapa ett mer hållbart ljus. LED, så låter det ofta när allmänheten och för viss del också en hel del tillverkare pratar om hållbarhet. Har vi bara LED så är det hållbart? Absolut inte, säger jag. Raka motsatsen. Kör vi bara LED och vi tycker att det har löst problemet så har vi snarare gjort världen mindre hållbar. Jag kommer tillbaka till varför det är. Det är idag snart 20 år sedan LED gjorde sitt intrång på belysningsmarknaden på bred front. Och det var en minst sagt revolutionerande teknik. Utöver en fantastisk energieffektivitet, extremt lång livslängd, så erbjuder helt plötsligt en ljuskvalitet som vi tidigare bara kunde fått genom vår kompis glödlampan. Glödlampan som alla vi som arbetade med ljus vurmade för just dess överlägsna ljuskvaliteten. Och även om de flesta av oss var lite skeptiska till formen på de här nya kompisarna, de var rätt fula som stryk till och med, så var vi det närmast lyriska för de möjligheter som dessa gav. Tänk bara vilka fantastiska ljussättningar vi skulle kunna göra på alla fasader och byggnader som tidigare legat i mörker på grund av oro för underhåll eller för en ohållbar energiförbrukning. Nu kunde de få liv. Men framförallt så såg vi den stora möjligheten att befrias från omänskliga miljöer som det här med undermålig ljuskvalitet och helt usel färgutgivning. Och i det här fallet ingen färgutgivning. Idag är det väl ingen som minns det här nästan. Men i LED:ns linda så fanns det fortfarande där. Och vi var minst sagt lyriska över vad som väntade. 2010 hölls en ljuskonferens i Stockholm på underbara fantastiska museet. Fotografiska museet. Det var fullt av svenska och internationella välrenommerade ljusdesigners på plats och alla vurmade för den nya ljuskvaliteten. Alla utom en. Det var genomgående hyllningstal till ljusets förunderliga, magiska förmåga. Och sen steg den här herren upp på scenen. Fernando Petat, Nando kallad. Och han var inte alls glad. Han spände ögonen ilsket i och så närmast röt fram. You should be ashamed! Ni borde skämmas. Chocken i rummet var ganska tung. Vi förstod inte riktigt vad som hände. Och det lugnade lite sen när vi fick reda på att Nando var astronom. Och Nandos ilska bottnade i det faktum att han inte längre kunde se ut i rymden. Upplevelser som dessa med Vintergatan tydligt avtecknade miljontals stjärnor är för de flesta av oss någonting vi får bara se på bild. Våra upplysta stadsrum har släckt ut det. Vi är berövade det här. Men för Nando och hans kollegor var det värre än så. Det visade sig nämligen att de under många år hade klarat sig rätt bra ändå, för de kunde titta ut i himlen bortom de våglängderna som i det här fallet med lågtryckssnåren bara var en. Fast ganska mycket man kunde titta ut genom bortom det. Men nu kommer man bättre ljuskvalitet. Och på sistone hade det då kommit in LED som helt nästan täckte igen de här hålen de kunde titta ut genom. Och Nando pratar såklart till egen sak, för hur skulle vi kunna värdera astronomens behov av utblick mot människans behov av att slippa det här hemska ljuset. Men Nando slår undan benen på oss en gång till genom att framhålla att det inte nog med att vi förstörde med vårt nya ljus. Vi var dessutom magstarka nog, fräcka nog och säga att vi gjorde det för att rädda planeten för att spara energi. Nonsens, sa Nando. Nando berättade hur han för 2 veckor sedan hade fått ett telefonsamtal från sin mormor i Italien. Som var jättelycklig. Hon hade gått i affären och hittat en lampa som bara drog hälften så mycket ström som hennes nuvarande. Så sa Nando, jättehärligt, jag köpte 2 så nu kan jag ha dubbelt så ljust i min trädgård. Nando var inte lika lycklig som hans mormor. Det här beskriver rekyleffekten, att energieffektiviseringar ofta går förlorade och effektiviseringar rent allmänt går förlorade för att vi använder mer istället. Det är sedan länge känt. Georgs paradox, som det heter på akademisk svenska, etablerades sedan 1865 och ändå verkar vi ha glömt den och missar den gång på gång. Vi kan med facit i hand titta tillbaka på rätt trevliga ljussättningar som den här, som för övrigt inte har någonting med vare sig mig eller Anel att göra, men jag tycker den är fantastiskt vacker. Riktigt fin och väl avvägd fasadbelysning. Men mycket av det som har följt har också gjort lite grann för att vi har kunnat, tror jag. Mer och mer förskräckligt, i alla fall i mitt tycke. Till någon slags fantastiskt jippo med crescendo som man knappt kan kommentera ens. En otrolig genomslagskraft såklart som ljuset har, men vi borde nog låtit bli. Allt det här är gjort med LED. Och inget av det kan betecknas som hållbart. LED eller är inte hållbart. Produkten i sig kan aldrig vara hållbar. Hållbarhet borde absolut vara högst upp på allas våra listor. Men för belysning ser jag tyvärr alltjämt att vi går lite grann eller rätt mycket i fel riktning. Denna normlösning ser vi fortfarande på bred front allt annat än optimerad för människor. Den kan aldrig anses vara hållbar. Den missar sitt grundläggande syfte. Det här är belysning för fastigheten, belysning för byggnaden, där vi borde göra ljus för människor. Och ändå är det lösningar som de här som framhålls när en massa nya och inte helt nya hållbara initiativ introduceras. Vi har en tillverkare som är stolt över att ha tagit bort en del metall och ersatt med kartong. En annan fokuserar just på kartongen för att minska volymen och frakten. En tredje har satt upp en hel produktionslina för att bygga om gamla armaturer. En fjärde har lagt till ett PR-namn, ett poppigt namn som ska poppa. Och en femte har lagt om hela sin affärsmodell för att sälja armaturer på ett mer cirkulärt sätt. Och så vidare. Nej, det här är inte för att prata illa om någon i branschen överhuvudtaget. Tvärtom, jag tycker att det här är initiativ som är hedersvärda och jag är säker på att de är framtagna med de bästa intentioner. I framtiden har de också en liten del att spela, men det är just det som är problemet. Jag tror det är en liten del. För i dagsläget är jag otroligt själv orolig för att de skapar mycket större skada än nytta. Inte enbart för att de bidrar till att upprätthålla omänskliga miljöer som de här, utan för att de avleder nödvändig uppmärksamhet för det som borde ges fokus. Användningen. Det här är koldioxidavtrycket för e-line. 96,7% kommer under användningen. Lite drygt 3% kommer från allt annat. Till skillnad från en stol till en undertagsplatta till en tegelsten. Allting i byggindustrin. Där det handlar om tillverkning, transport och återvinning. Så för belysningens bit så är det inte ointressant. Men det bannar mig inte där vi borde lägga fokus. Det finns 96,7% att lägga fokus på. Om någon har koll på detaljerna så klart, de här procenten som jag visade precis beror på lite grann vilken elmix vi tittar på och var den är producerad någonstans. Så det är absolut sant. Ser vi till hur det ser ut så har Sverige ganska ren produktion. 15 gram koldioxidekvivalenter per kilowattimme. Medan Tyskland, där vi skickar det här utifrån, 500, det är nästan så jag skäms för att använda strömmen här nere. Samtidigt får vi komma ihåg att de här näten är ju helt sammankopplade. Det märker vi inte minst när vi ska betala vår egen elräkning. Så om vi slösar bort en enda kilowattimme i Sverige så betyder det att vi måste producera någon annanstans när vi hade kunnat exportera den. Så vi bör absolut vara väldigt måna om vilken energi vi gör av med. Sebastian kommer att återkomma mer till miljöpåverkan från produkterna. Men innan vi tittar på produkter så vill jag påminna er om det mest centrala. Och det är ni som föreskrivare. För vi vill skapa mer hållbart ljus, då måste vi börja med god ljusplanering. Det är A och O, A, B, C, D, E, F. Någonstans nere på G på skalan kommer sen ljusstyrning som behöver vara klok. Så vi har rätt ljus på rätt plats vid rätt tid. Väldigt långt ner, någonstans P, Q, R, varför nu blir massa bokstäver. Där kommer den hållbara produkten in. Inte ointressant. Men om ni börjar där, om ni lägger för stort fokus där, så kommer ni att missa den stora påverkan ni kan ha genom god ljusplanering. Vi måste i grund och botten sluta med icke hållbar belysning för fastigheter och istället fokusera på ljus för människor. Ljus där det behövs som mest. Tillsammans med ljus som gör att vi ser rummet och håller oss vakna. Tillsammans med ljus som är dekorativt för att vi behöver kontraster och någonting ska hända. Och i det här läget börjar vi skruva på dimmern, för det har de väl sagt till era beställare i alla tider och för de som är beställare. Dimmern är lika självklar för belysning som volymkontrollen är på allting som gör ljud ifrån sig. Och när vi börjar skruva på de här, då ser vi att vi kan skapa miljöer som i det närmast blir hemmalikt. För någonting som från början var sjukhusliknande, icke hållbar fastighetsbelysning, så har vi skapat en mångt mycket mer hållbar, inbjudande miljö genom god ljusplanering. Grå sörja som denna måste bort. Alltså det är bara så. Det finns så oerhört mycket bättre lösningar. Om vi ska ha det helt infällt, eller om vi vill jobba med diktmontage, eller för all del är som vi bör jobba med mycket mer pendlade lösningar. Kanske som här, placerat med och monterat i belysningsskenor så vi enkelt kan flytta armaturerna inom rummet, mellan rummen, mellan fastigheterna utan att ringa en elektriker. Belysningen behöver inte vara statisk alls. Handlar då ingenting om produkt? Jo, självklart behöver ni också göra ett gott val där. Men det handlar främst om att blicka framåt. Inte så mycket återanvända det som för många gånger är fel från början. Det är fruktansvärt dåliga anläggningar många gånger som vi försöker återbruka. Tyvärr behöver vi bara dra ett streck i sanden och säga att vi har gjort en massa trams, nu behöver vi jobba bättre framåt. Och när ni väljer nytt, vad ska ni välja då? Ja, ni kan absolut få välja en armatur i hampa om ni vill det. Det här är ILO som Ledux tillverkar. Men jag tror inte det är det som ni kommer att göra det största miljöuttrycket på. Jag är ganska övertygad om att det inte är där det gör. Utan det ni kan jobba med istället är hög modularitet. Det är i alla fall så närmare ett svar jag kommer. Hög modularitet som gör att vi enkelt kan skifta när verksamheten skiftar. Vi kan låta skalet sitta kvar och vi kan dra ut insatsen och göra om från ett kontor till ett café, från ett café till en affär. I ILOs fall så sitter drivdonet med 2 skruvar av säkerhetsskäl. Allt annat är bara snäppfästen. Vi kan bygga om armaturen utan en elektriker. Utöver en hög modularitet, bara lite kort för att pitcha ILO, så har den väl i stort sett marknadens bredaste sortiment. Massa smarta detaljer för enkel installation, långa linjer helt utan läckage i skarvarna och hur många möjligheter som helst att spesa upp den som ni vill. Och allt det här kommer till ett extremt konkurrenskraftigt pris. Så om inte jag har någonsin varit en säljare så fick jag vara det nu. Om ni någonsin behöver en profil, gå till ILO. Jag är nästan övertygad om att den kommer att vinna när ni jämför alla datan som finns tillgängligt. Men samma tänk är numera plain uppbyggd. Ni vet den här fantastiska pendelarmaturen som Kai Pipper har designat. Den gamla fönsternischen med en liten öppning som ger ett större ljus som gör att vi inte blir bländade. Fin visuell komfort samtidigt som vi får en vacker armatur. Den kommer en helt uppdaterad modell nu, plain 3. Förutom den här grymt fina, vackra bronsfärgen så är den uppbyggd numera modulärt, likt ILO. Vilket inte är helt tokigt, för helt plötsligt kanske vi ser när vi har valt den här mikroprisman att jag skulle vilja ha lika bra avskärmning i längsled som i tvärsled. Och då kan jag utan verktyg på plats klicka ur min modulinsats, min mikroprisminsats och stoppa in min Office Basic. Helt utan multipla skuggor. Och helt plötsligt har vi skapat en ny arbetsplats. Om ni behöver skifta applikation oftare än så kanske ni ska ta steget fullt ut och tänka på någonting som i grunden är trunking system, som E-line. Utöver ett tekniskt prestanda som är helt marknadsledande, valmöjligheter i oändligheten, så är det enkelt klick i, klick ur på plats. Och det här är snäpp i, snäpp ur. Här går det snabbt och här kan vi byta om. Vi kan göra om belysningen varje dag. Och någon som säger att det känns som att den är mest anpassad till industrin. Nej, men den funkar absolut i industrin. Men den fungerar egentligen överallt. Den fungerar i retail utan bekymmer. Den fungerar i en kontorsmiljö. Den fungerar i en skolmiljö. Skulle ni använda den till skolor så skulle jag uppmana, gör inte de här kontinuerliga linjerna som ni ser på bilden här. Det blir liksom platt en gång till. Det finns en insats som har 28% uppljus och en bredare nedljus i mikroprisma. Fantastisk visuell komfort. Och vi får ett uppljus i taket som gör att taket lättar trots att det är diktmonterat. Sen bryter vi upp det, stoppar in sportinsatser emellan och helt plötsligt kan vi modulera, bygga upp hela rummet. Tycker ni kantigt formspråk är tråkigt så kan ni gå på ett runt alternativ som heter tugra. Samma sak där ungefär. Modulärt uppbyggd, allting går att byta ut, allting går att komplettera. Användbar i en uppsjö miljöer. Från industri, absolut, till kontor, till affärer, till skolmiljö. Om ni inte vill fastna i det här med formspråk då, runt eller kantigt eller hur det ska vara eller vilken färg, ja, men titta då gärna på Kamaleon från Trilux. Det här går skalet att byta. Det har inte jag sett hos någon annan tid i alla fall, så där tänker jag är riktigt, riktigt häftigt. När vi byter skalet så kan vi helt enkelt skifta design utan att vi kan ha god design över tid även om trenderna skiftar. Och när vi tröttnar på den här platta gråa ytan så kan vi få den veckad. Samma profilstomme. Vi kan byta insatser precis som vi gör på ILO. Minimerad miljöbelastning genom god design. Föränderligt utan att vi gör ett stort avtryck på vår planet. En och samma stomme. Pratar vi den lite mindre skalan så slår jag gärna ett slag för Knoche, vår egen spotlight. Modulärt uppbyggd, enkel utbatbar lins på plats. Mycket ljuskvalitet för pengarna. Och pratar vi ljuskvalitet så kan jag inte låta bli att nämna Daisy, vår egen lilla infällda downlight. Utformad med ljuset i främsta rummet, och det skulle jag väl säga som ljusmänniska är första steget i hållbarhet att se till att allt ljus gör absolut nytta. Modulär konstruktion, vi kan byta ut linserna i efterhand för vi linser istället för reflektorer. Både för att det är bättre ljusbehandling men för att vi ska kunna byta dem på plats. Finns i en fast version eller en ställbar version. Där den är ställbar upp till 35 graders vinkling utan att den trillar under undertagslinjen och utan att vi får ett kraftigt islag i stommen. Det är bra ljus. Som sista produkt, nu är det snart slut här, så kan jag inte stå i en Trilux-lokal utan att framhålla världens bästa downlight, Sonos. Sonos med sin fantastiska convision lins. Den framstår kanske inte i första läget till att vara lika modulärt uppbyggd som mycket annat, men det är den under ytan. Allting går att byta ut, allting går att dela. För det är den här framtiden vi måste in i, där vi inte bygger någonting, limmar ihop det och slänger det, utan där vi faktiskt kan underhålla enskilda delar. Med den kavalkaden av produktpitch så ska jag lämna över till den verkliga experten på ämnet. Dr Sebastian Knoche, welcome to the floor. The stage is yours. There's the clicker and I will come back with questions for you later.
Yeah, thank you very much, Jim. So I did not understand anything about the Swedish parts which you said, but did it involve something about complex things in the very beginning?
It might have said something about complex things. Very complex.
Okay. So you are lucky because I'm a physicist, and physicists tend to make things as easy and simple as possible. So although sustainability is a complex topic, I hope that I will explain it in a very reasonable way to you. And I will begin at the very beginning. What is sustainability? And I like the definition of the United Nations very much. They say sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Or in short, as a physicist, to act in a way that we can continue doing so forever. The United Nations have a list of 17 sustainable development goals, and these are about the really great challenges of humanity today. It is about peace on earth, it's about a good life for everyone, and it's about not doing harm to the planet. And when we at Trilux are doing research projects on sustainability of luminaires, we are mainly focusing on the third aspect, on not doing harm to the planet. And there we must state that we are part of the problem. We are mining for materials. We are putting them into production facilities all over the world. We are using the luminaires for quite a long time. And after that, we are putting them into a very simple form of recycling. So we are part of the problem. And just to name two of the problems, one is the global warming, which we are contributing to. And the other one, which I would highlight here, is the use of abiotic resources, which are limited on Earth, like minerals, metal ores, and so on. So a bit detail on these two impact categories might be needed, starting with the global warming potential. Some of you may have seen this series of colors already. It's called the warming stripes, and they are quite well known by now. The data behind is very simple. It's the global mean surface temperature from 1850 until now. and it's the average value per year. And you can see that there are a lot of variances in the global temperature change, but that the trend is clearly visible and clearly much more than the variances that we can see. Then you might still think, well, this trend, it is like 1.2 degrees increase so far. Is that relevant? Or in any case, because outside it's in summer, it's plus 30 degrees Celsius. In winter, it's minus 20 degrees Celsius. So what's the big difference if it's 31.2 degrees Celsius outside? But to understand how significant this difference is, we need to look at a larger time scale. And if we make this trend that small and look what has happened before, we can see the evolution of the global temperature over the past 22,000 years. And yes, there have been a lot of variances, but in the last 10,000 years, the climate was in a very stable state. And this last epoch of Earth history is called the Holocene. It is the desirable state of a planet. Its climate has been changing only about plus minus 0.5 degrees Celsius. So the large deviations we had before, this was really ice age, like you know from the movies. So with mammoths wandering through Spain and with glaciers ranging up to Hamburg or Berlin. At the beginning of this warm period, before 10,000 years, there were about 8 million people on the Earth. It were less people than elephants, for example, but they did something special. So they started to settle down. Say they invented agriculture and formed advanced civilizations only in this time period of the past 10,000 years. And by that, they grew by a factor of 1,000 to have 8 billion people on Earth right now. And this large society is just adapted to this stable climate of the last 10,000 years. And you can see now how fast we are screwing up this stable state of the climate within just 150 or 200 years, beginning with the Industrial Revolution and beginning with the burning of fossil fuels, which is the underlying reason for that. So looking backwards in time, it's quite a good idea to limit this global warming. That should be enough on the topic of global warming. Let's come to the other aspect, which I would highlight today. It's about the abiotic resources which we are using in luminaires. The environmental scientists, which we are working together with, use a metric which is called the abiotic depletion potential of the elements in order to determine how many abiotic resources are being used in a luminaire. And it works like this. We are looking into the luminaire, which substances, which chemical elements are inside one luminaire. And then each element gets a weighting factor, which describes its scarcity. And then with this weighting factor, you can add up all the individual substances of the luminaire to get the value for the abiotic depletion potential, which is then measured in the unit of kilogram of antimony equivalent. These weighting factors for the different substances can be very different. For example, for aluminium, you have a very, very small weighting factor because aluminium is the third most common element in Earth's crust. Whereas gold has a very high factor because gold is very scarce. So fun fact, all the gold which has been mined today would fit into a cube, which is just 22 meters in side length. So we are a part of the problem, and we must also state that we are a significant part of the problem. We cannot neglect ourselves. You can see it from this number alone. 13% of Germany's total electricity use is for lighting. And in Germany, the electricity generation is the largest emitter of CO2. And being responsible for 13% of that as the lighting industry is quite a lot. And our life cycle assessments show that we are equally significant for the resource use which we are causing. I mean, you can think for yourself, how many luminaires are there for you? We are surrounded by artificial light and by luminaires everywhere. You have several of them at home. You have workplaces which are equipped with maybe 4 additional luminaires. Then we have the street lighting, which you can see in the slide here. Okay, we must say street lights, they are shared among very many participants of circulation. But if you think for yourself, you can add up quite a total of luminaires which has been produced for you so far. And that's the reason that lighting is such a common product, that we are significant in these 2 problems of global warming and of abiotic resource use. And we are also part of the solution. So let us first look at the global warming potential. So these are now the results from the research projects that we did. This is the result of a life cycle assessment of one E-line, which you can buy right now. And this is representing the global warming potential over the complete life cycle. You can see in orange the contribution of the use phase, which is in this case even 99% of the complete CO2 emissions. And for the production, we only have 1% of the CO2 emissions being generated. And of course, so these are the values for Germany. It's an electricity mix which is not that renewable as you have in Sweden, for example. But also in Sweden, the use phase still is the dominating part of the life cycle assessment. So if we go back to the older versions of the luminaire, you can see that you need more and more CO2 emissions for the life cycle of 70,000 hours. And going back to the old T8 E-line luminaires, you can see that you have twice as high CO2 emissions for the E-line because its luminous efficiency is only half the value of what we have today. And for the future, we are, of course, developing our E-line further. And you can see that the new E-line Pro, which will be available somewhere this year, will even have a lower CO2 footprint. You can also see that the improvements are getting smaller and smaller. And from the LED development itself, we cannot promise too much for the next 10 years, maybe another 10% in efficiency gain. But we need to find other solutions to get more sustainable or reducing the CO2 emissions more and more. And one key point is using light management systems, like, for example, the LifeLink management system, which we are selling here at Trilux, and which we have been developing until 2015. And this gives you, by means of daylight harvesting and presence control, easily 30% of energy savings. Some standards even say that you can calculate with 50% energy savings, which is a little high from my opinion, but the standards say so. So these are the improvements on the CO2 emissions so far. What do we have concerning the material resources, these abiotic resource depletion? For the E-line, the answer is also very good because you can keep your old E-line trunking system and replace even the old E-line T8 luminaires with new E-line Pro luminaires. So you can keep the trunking system and just continue using it. And our life cycle assessments also show that the luminaires have done some improvements over the past generations. So these are the results for the abiotic depletion potential for the E-line LED up to the E-line Pro. And from the legend, you can see where we have the major contributions. So maybe I can highlight it. You can see this blue portion is the wiring, which is mainly contained in the trunking system. And it's the copper which has this high impact here. In the case of the E-line, you can just reuse it. You can continue using it. Other main contributions are from the control gear. This is the darkest blue part of the diagram. And for the old E-line LED, we had a very large contribution by the LED module. So in general, you can see here that the electronics components contain the most precious materials, much more than, for example, the optics or the housing, which is usually made of steel or aluminium. So what happened here that we improved the LED so much from this block to just this tiny block in the E-line next? The key was to reduce the LED module size and to employ special LEDs. So in the old E-line, we had LEDs which were equipped with a bond wire. A bond wire is used to connect the LED chip, which you can see in blue here, to connect the LED chip to the rest of the LED package. And this bond wire is being made of gold, one of the scarcest substances that we have. And we have them in these types of LEDs. What we replaced them by were flip chip LEDs. And in flip chip LEDs, you can see on this, this is the emitter chip, there are no bond wires anymore because the flip is contacted from below. It's a bit tricky in the production because the chip has to be flipped during the production. That means these flip chip LEDs are a bit more expensive than the traditional ones, although they don't contain any gold, but they are in many senses better than the old ones. And this was the key to reduce the abiotic resource use from the E-line LED to the E-line Next, and which we are keeping for the E-line Pro also. We are working on even more challenges. For example, in the last research project which I had, we did a research on the recycling of luminaires, how it actually happens here in Germany. And the first step in luminaire recycling is always a simple shredding of the complete luminaire. And you can see what happens if you do so. You can recover the ferrous metals, of course, and also the non-ferrous metals can be sorted quite well from the stream which comes from the shredder. But the plastics, for example, here we have a problem. Or also, if you take glass sheets, for example, in a luminaire, we have a problem because they are shredded to so small pieces that it's impossible to sort them after it. That means that for things like glass, plastics, we must assume that this only goes to the landfill or to the incineration in case of plastics. It will just be burned after the recycling and not being transferred to new substances and new plastics. That's a pity because the plastics which we are using, like PMMA, polycarbonate, is in theory recyclable. So they are thermoplasts, they could be recycled if the recyclers chose to do so. Summing up all the results which we got, we are presenting this slide of the recyclability assessment of different luminaires. The percentage gives you the weight percent of the recycling yield, and the left column of the diagram always shows you the material composition in the new state of the luminaire. The right hand column shows you what remains of this after the recycling. And let's, for example, compare the luminaire on the very left to the luminaire on the very right. It's 84% versus 22% of recycling. This is our Creavo, to name it, and this is a typical flat panel luminaire, Ciela, Arimo, and so on. You can see that in the Creavo case, we just have very small pieces of plastics in the optics. And they are getting lost in the recycling, but the main material, this blue portion of the bar, is steel, and this survives the recycling to more than 94%, I guess. If you start with a luminaire which with a material composition like this, that PMMA sheets have the main weight of the luminaire, and PAT, the polyethylene, has another share of the weight of the luminaire, this will get lost in the recycling, and you are just ending up with the aluminium frames, which you can from the recycling. So this explains the low value of 22%. You can also compare, for example, our E-line with 73% to a similar luminaire, one of these weatherproof luminaires, which have housings made of polycarbonate, which then turn out to be less recyclable, just because plastics is usually being sent to the incineration in our current recycling practices. So this is a definition of a further problem of further research activities, but I hope that I could convince you that we have already solutions at hand, and you can also be part of the solution. So what you have learned today should be, on the one hand, of course, use LED luminaires instead of the old fluorescent lamp luminaires. And we know that in the field, there are still a lot of the conventional lighting being installed. And use light management systems if it's possible for you. Go for high efficiency and high quality lighting. For example, invest in a luminaire that uses flip chip LEDs, which are saving the abiotic resources, which is, for example, in the E-line, in the high efficiency variant at least, and in the E-line Pro too. Go for these high quality luminaires, and I think that's what you can do to make the lighting business more sustainable. Thank you very much for the attention.
Thank you extremely much, Sebastian. Now let's see if we're back in screen and we can see ourselves. Oh, no, lost there. So thank you very much. The reason why I'm standing here giving this presentation in Trilux rather than giving it in Sweden is because I so much wanted you to be part of this presentation.
Thank you.
Not just because you're a brilliant person who knows a lot of stuff, because, as you said, physicists always explain things very easily. That was the opposite that was true, of course. You explain it easily, but most physicists doesn't. And you gave a fantastic presentation when we had a Trilux party in Malmö, and you were actually requested by someone who was there. Oh, I wanted to see that again. So that's how big of an impression you make. So thank you very much. We have hopefully got some questions in. I will let Robin give them after. I can't stop myself from giving the first question though. since that was almost in the heading of the webinar, is there in fact such a thing as sustainable lighting? Can we claim that we have sustainable lighting?
Yeah, that's a difficult question, rather philosophical, I would say. So from the pure technical point of view, we cannot claim that lighting is sustainable. So there are standards which say standards about environmental claims which a manufacturer can do, who say that sustainability is a complex field, and that up to now there's no standardized way to measure sustainability or to document it. So we are not even allowed to say that lighting is sustainable right now. So taking it more philosophical, I would say we can reach a situation on Earth where lighting is sustainable, but we have to do a lot still for that, especially cutting the CO2 emissions, which we are causing. But that's only in part in our responsibility. The energy transition also has to occur, especially here in Germany. We have big challenges with that, but we are working on that. Yeah. You are done already in Sweden, I guess.
Depends on how you look at it. I'm sure someone would say that it isn't the complete true picture if you look at hydropower and everything, what that does to fishes and everything. So the picture becomes complex very, very quickly.
Sure.
And it is a trick question. And I kind of asked it because, in my opinion, I think we should stop saying that we produce sustainable lighting. We should focus to do light that's more sustainable than the alternative. But claiming that it is sustainable is kind of like, well, it's hitting the wall from the very beginning.
It is, yeah, but that's possible. So we can have a look at the life cycle assessments of one luminaire and the other luminaire, and we can see which generates the less environmental impact.
Yeah. I will do one more. I have a lot of questions, so if the audience isn't quick enough, I will take up all the time. So make sure that we get the questions in. Before that, though, looking at. I claim in my presentation that I'm afraid that and I'm worried that a lot of effort and focus is put where there's very little impact. So basically, we're focusing on what can we do with the plastic, what can we do with the metal, what can we do, which is taking away necessity of looking at the use phase, which is still the highest proportion of it. And would you say that I'm exaggerating in my?
I would agree that a lot of the green activities have the things in focus which are easy to be explained to the customer, and which do not have the highest impact if you look at the pure numbers from life cycle assessments, which the environmental scientists give you.
And in all the diagrams that you showed, because this was something that intrigued me, looking at the diagrams. When I look at it, and if I transform it into my own way of thinking of it, if we rebuild an old luminaire, we are still going to be stuck with all the problems we have with mining, all the problems we have with electronics components. We still need to produce all of that, which is the biggest impact of all in the production cycle, I think.
For the abiotic resources, absolutely. So the most precious materials is in the electronics, in the LEDs and the control gear, not in the housing. That's for sure. And also from the perspective of the CO2 emissions, that's another of these metrics which we have to consider. The production phase does not take too much CO2. You could reduce it a bit by, for example, reusing old gear trays from the E-line or from other luminaires. But you must be sure that you are not having a negative effect on the efficiency of the luminaire, because this is the 99%. If you have like a 2% worsening on that, you are doing more harm than you could potentially win in the 1% for the production.
Yeah. That's thought worthy.
So I would agree to you.
You would agree. Yeah. You would agree. Okay. Robin, do we have any questions from the audience?
Yes, we have some questions here from Stockholm.
Yeah.
Do you think EPDs are a good way to present environmental impacts of products?
They are better than doing nothing about the data, I would say. But EPDs also have their problems. So, for example, it is very difficult to compare the EPD results, so the life cycle assessment results, from one luminaire to another luminaire from another manufacturer, because there are so large uncertainties in the data which is needed to produce such an EPDs. There are so many estimations and so many boundary conditions which the different manufacturers can set separately. You need a very deep understanding of the EPD and of the life cycle assessment included in the EPD in order to have a real picture of the environmental impacts and which luminaire is better. So I think it's okay to compare luminaires from one manufacturer where all EPDs have been calculated to the same method. And that's also what we are doing in our development, to see the life cycle assessment of concept A, concept B, concept C, which is the most sustainable one. I think that's good, but be aware of the limitations and of the challenges of the data inaccuracies, especially across different life cycle assessment bodies and different manufacturers.
Does that still apply? Can't that be standardized? If they apply even more standards to how an EPD is done? I think it was just less than a year ago that the Lighting Europe agreed on which, what's it called? PCB? No, it's not called PCB.
PSR.
PSR.
Product-specific rules, yeah.
Precisely.
Exactly, that's the next step in standardizing it. Even then, you have a lot of uncertainties. So one uncertainty which, for example, also the standardization bodies cannot solve is the data sources which you use. So nobody can really measure how much CO2 was being used for producing a steel gear tray, for example. You have to rely on background data. And this background data comes from databases, and you can use, so who is experienced that, Eco-Invent, for example, Sphere database, but they have different values. So it depends on the software which you are using, what your results can be. So you must stick to one database, but I think it will be difficult for the standardization bodies to prescribe you must take the Eco-Invent database, for example, because that's a bit, it's hindering the competition in this field.
So even with more standardization, even with more rules, it will still not be an exact answer. You will get an indication, perhaps.
And you really have to dig deep into the data to completely understand it, the estimations, all which went in, and then you might be able to compare it.
Okay, yeah. Do you know? Side question completely. Do you know the price of producing an EPD?
I don't know it, although I'm currently involved in these projects, but I, as a physicist, like to get out of this business. Yeah, but it is quite expensive. That's a bit frustrating, because we could also invest that in improving and not just documenting. But I see that we also need to document, and that we need to make it measurable, the environmental impacts.
Yeah. The number I've heard is that it starts about 10,000 euros for one product.
Okay. Yeah.
And then there's just so many things you can do with one product when it's still in a product, and you need a new one.
Yep.
So it's a massive amount of money, which is absolutely fine as long as it's used. But I'm a bit worried when the background is that you can't really compare it unless you know a lot of it, and the standardization isn't really there, and it's asked for, but maybe not used. Just put it.
So you are a lighting designer, and you talk to actual customers. I'm a researcher. I never talk to customers.
No.
So
they ask for it.
What do you think? What do they do with it, with an EPD?
Are we being honest here? No, I think normally for some projects, the EPDs are used if there is a specialist working with them. I think with all respect to the lighting community, there's so many things that you need to know and you need to master as a lighting designer, as a lighting planner, as a lighting specialist. Also being able to analyze an EPD in a correct way is beyond your scope. So I think a lot of it is actually asked for by a demand that's put above without really knowing what to use it for, and hopefully it has a positive impact by putting pressure on manufacturers to kind of look into details. But from my perspective, the request compared to the output is unrealistic. There is no connection.
Yeah, so then it's more a proof that the manufacturer is involved in sustainability and is looking into life cycle assessments, and that's then the only benefit so far.
But then again, EPDs doesn't have to be third parties. So some EPDs are, depending on which standard you use them on, you can also do your own EPDs, I think. Yeah, that makes it even more conflicting.
Yeah.
Okay, sorry. That was a long answer, Robin, and I made it even longer. More questions?
We have one more question. Will recycling of plastics in luminaire be better in the future?
I hope so. Yeah.
That's actually one question I had. Recycling through shredding. It sounds like Stone Age. Are we still there?
It is still there. So at least in the facilities which we have visited in this research project, and I would guess that it's similar all over Europe. So we had this presentation, for example, at Light in Europe, and the feedback from the audience was also from other countries. That's the same situation there. But we need to get beyond that. But it's not an easy task. So what we had in mind when starting this research project, we wanted to make a design for recycling. So we wanted to think the luminaire from the end of life, to optimize it for the recycling. But it's ridiculous to optimize a luminaire to this simple process where everything gets shredded. Then you can just say, okay, we have to avoid plastics in luminaires. But we were thinking maybe, that you can manually disassemble the luminaire. But as long as that's not happening, you don't need it to be designed into the product. And other way around, if the manufacturer, if the recyclers do not get luminaires, which are easily dismountable by hand, for example, they will not change their processes. And I guess that even more pressure on the recyclers is needed, for example, that plastics may not be incinerated anymore, to make a real change. So what we found at the end of this research project was a field which needs many more research projects and activities with recyclers and manufacturers, which go hand in hand to improve process and product for the future. But we need to get that.
One of my the closest thing to an answer I get, because as I stated in the beginning, I try very much to stay out of answers when it comes to sustainability because it is too complex. But one thing I believe is at least part of the answer is modularity. I mean, if you produce things to be very modular, and not just modularity in the case of having different modules that are glued together, but also modularity in how it's assembled. How do you think that would help? I mean, if it's too less to separate the plastic from the rest, boom, would that help?
I think that would help. So maybe the optimal luminaire from the recycling point of view would be something which you just slide over a table, maybe through some heavy things, and then it falls into all the pieces, and then it can be sorted into all the materials. That would be, I think, then it might also be appreciated by the recyclers that they can invest in such new kind of disassembly of luminaires, for example.
Because I mean, walking around the Trilux factory, you can see a lot of recycling being done in the production by plastic that is kind of reused and good. Not from old luminaires, but from the granular that you're melting.
Correct.
You're taking away all the things that are being cut out. You're putting back into production. So we can absolutely handle it, and we just need to make sure that we get it to someone who actually handles it without burning it up.
Correct. And so then we have fields for more research, because when the luminaire has been in the application for 20 years, I mean, we have luminaires with 100,000 hours of lifetime. It can take in an office application like 40 years. What happens to this plastics during the 40 years? And you can have paint on it, bees and so on, which have died in the luminaire. It's also no brainer to recycle this post-consumer plastics after 20 to 40 years. But I think we need to accept the challenge.
But if we stick away from flat panels, then we're sticking away from a lot of the plastics. Then the flat panels are 60 by 60, the Ciela or whatever we in Trilux names call it. Then that's predominantly which we saw in your graphs as well. Massive amount of plastic. So that's another take. Om vi inte vill ha LED-plattorna, vi kan inte ha dem av hållbarhetsskäl. Det handlar inte bara om dåligt ljus, det är också skit och återvinna det, och det går åt helskotta för hela världen om vi har dem. Sluta med LED-plattorna. Det behöver inte säga till er, men gå på era beställare. Vi får sluta med det. Sorry, I turned into Swedish there. Told them to not use flat panels, which they don't use anyway. So I was preaching for the choir. Okay, Robin, anything more? Otherwise, I have one that I can end with.
We have a question from the audience.
Cool, let's do that instead. I talked too much.
When it comes to the use of metal in old luminaires, isn't it better to let those metals be recycled and used in newer luminaires that use less metal than old ones? Or is it still more beneficial for the environment to retrofit with LED in old luminaires and keep the metal locked for a longer time?
So that depends, of course, how much material savings you can get in a new luminaire. So I tried to find some figures on this question because I found that very interesting, that question, but I did not really have a success there that I could say that new generation luminaires have X% less metal than old generation luminaires. So difficult on that side. Concerning retrofitting, I think you have to look more on the efficiency in the use phase, because again, the 99% is in the use phase, 1% for the production phase. And I think the retrofits are mainly less efficient than a proper LED luminaire. So from the CO2 perspective, it is good to invest into this production of a proper new luminaire and then have the benefits over the use phase instead of using the simplest system. Would you agree?
I would absolutely agree. I mean, I love that question. Thank you, dear audience. One of the things that have been kind of troubling my mind is if you take a steel luminaire, not a new aluminium one, but a steel luminaire about this big to house 3 T8 luminaires and aluminium reflectors in there, and you rebuild that to a new LED that is this small to begin with, that needs a completely different set of optics, that need everything. Why should the housing be this big to begin with? If you melt this down and you make 3 houses that are the same size, so I would say without then. And this is me just guessing. You've actually looked into it and you couldn't really find the answer.
No, not really.
But I would, my common sense, if there is any, would say that there's at least a big risk of it. And even if there isn't, you strike the complete point by saying efficiency. And by default, I would say that by rebuilding something old, you will get less efficiency than by doing something that's designed correct from the very beginning.
It's very likely. Yeah.
But I think the biggest problem is the amount of rebuilding that's done almost on site, because then you're sticking with the grid system that you had to begin with, that you don't even know that was correct to begin with. I was an electrical consultant back in 1999, and we didn't do any calculation. Someone said you needed about 5 luminaires per 20 square meters. And then we had that basically. I mean, so all of those things that I did myself, I'm ashamed to say 25 years ago, if they are rebuilt, they're going to be rebuilt. And some of them are going to be 780 lux. Some of them are going to be 370 lux. And there's a lot of waste in between. So just keeping the housing is you're absolutely doing the worst thing you could.
Yeah. Okay. Yeah. So redoing the light planning is a crucial aspect. Yeah.
Good planning, lighting control, and then sustainable products.
Okay,
that was in Swedish. So again, addressing the audience.
So I think there's a point for these refurbishment kits. I mean, you do not need to take a retrofit. You can also have a specialized refurbishment kit for a special luminaire which you want to keep because of its aesthetics,
architectural. If it's built in, there's a lot of factors where you can use it. Absolutely.
Yeah.
But it's a general rule to do it on any sort of lighting.
I think we are agreeing there.
We are agreeing, or I forced him to agree.
No.
Okay. We are almost up on time, and I always waste too much time. So I would suggest if you have anything else to add, we add it. Otherwise, we round off and say.
Thank you very much, Jim.
Thank you. Fantastically, I would shake your hand. That's how pleased I am. Thank you very much for this. Thank you very much, dear audience, for listening in, and stay tuned. There will be more webinars in the future. Cheers.
Goodbye.